The first part we're going to do is, you can see that there's all of these involve the same bar. It's going to have it's 2 meters long. Here's the bar, maybe. There's the bar. Okay. And it's going to have 2 point masses at the end. We know the masses of each one, and we know the amount of each bar. Okay. But how we rotate it is what's really going to make a difference. For the first part, we're going to rotate it through the center. Okay. If this is the point of rotation, this isn't like a mass or anything like that. If this is the above view, it would rotate like this. Okay. So it would rotate around, like in a circular direction around that center. Okay. So if that's the case, the 2 points are going to act like point masses. So the moment of inertia is going to be 2m1. I'm going to call the mass of those m1 r squared plus m2, that's going to be the mass of the bar, L squared over 12. If you look at your table, it's going to be spun from that. It's going to be spun from the center. So the bar spun from the center has a moment of inertia of ml squared over 12. So we plug everything in. It's going to be 2. Those are 0.5 kilograms, not 0.8. It's a bad looking 5. And because we're measuring from the center to the edge, the distance is going to be 1 meter squared plus the mass of the bar is 4 kilograms. And the bar's length is 2 meters squared, all divided by 12. Okay. If you solve the first part, it's equal to 1. If you solve this part, it's equal to 1.33. So if you add them together, you get 2.33 kilograms meters squared. Okay. For the second part, we're going to have the exact same thing. We have the same bar. Okay. But instead, we're going to spin it through this point. So that radius is going to be like spinning it all the way. I know this isn't a very good circle, but it's going to be spun all the way around that way. Okay. So I didn't want to spin it, make it go the whole way because I wanted some space to work in. So the first thing here is going to have actually a radius of this point here. The point mass here, it's going to have a radius of 0, so it's going to have no moment of inertia. It's going to spin just through the center. So when we look at its moment of inertia is going to be m1 L squared, because it's going to be the whole length of the bar from the center to the edge, plus m2 L squared over 3, because again, this time we're spinning it from the bar. And that's going to be, again, the points are 0.5 kilograms. L is going to be 2 meters, because we're going all the way to the edge. Plus, the bar is 4 kilograms. And it's 2 meters, quantity squared, all over 3 this time. All that's going to be equal to, the first part's going to be 2. The other part's going to be 5.33. That gives me 7.33 kilograms meters squared. The third one, part C, is going to be an axis parallel to the bar through both balls. So we're going to actually have, here's our bar again. We're going to draw it. But this time our axis is going to go right through the center of the bars. Okay. So we're going to spin it, and it's going to actually spin in like this direction around there. Okay. Which means that, again, assuming that the point masses here are really, really small, okay, the radius is going to be 0 for all of them. So in this case, I is going to be 0. Because it's not spinning really anywhere. The radius is very small. So we're going to call the moment of inertia 0 at that point. Really, technically, it's probably a little more than 0, but it's pretty close to 0 as long as those masses the radius of those point masses is very small. The last section, part D, has to do with if we have a bar, the same bar, but now the x is going to be parallel to that bar. So it's going to be like that at some distance, like 0.500 meters away from it. So, which is kind of weird, which means it's like spinning around that axis. Like a point mass, really. If you looked at it from above, let's say this is the axis right here, it would just look like a little point mass, the whole bar by itself. And it would just be spinning around like this thing. Okay. So really it's just going to be a point mass. So I is just going to be m1 plus m2 r squared, which is going to be 1 plus 4 kilograms times 0.5 meters squared. Okay, that all works out to 1.25 kilograms